Welcome to lesson 6002, order and interval notation. So let's talk about how we order and note numbers. Okay, let's deal with inequalities first. Here are some inequalities, but what are inequalities in reality? Inequalities list a range of numbers. When you solve an equation, you get one number as an answer, but when you solve an inequality, you get x is greater than 5. This means every number greater than 5. And you're used to seeing this on a number line. 5 on a number line on a horizontal x-axis, x representing real numbers in a horizontal way. You would see an open circle and you would draw your arrow going towards positive infinity. Now, what I want to tell you is if you always keep your variable on the left, the direction arrow of the inequality will point the way of the inequality. So if we took something like x is less than or equal to, 2. So we would draw a number line, which indicates all numbers, and we will write 2. We will close the circle. Remember, if it's included, it includes 2. Your open circle from above does not include the number 5, but every number above 5. Because our variable's on the left, the direction arrow goes in the same way. Now, we also need to talk about compound inequalities, which talk about a group of numbers that's bound by some dimensions. So, if we say and, it's all the numbers between two numbers. So the numbers between -3 and 1, where -3 is not included, but 1 is. When you see the word or, you see two number systems separated. So all the numbers outside of the in-between numbers. So and is between, or is outside. Let's see an example of this, which we have. So if I show you this, a number line, and I put 3, and I make it open, and make 5, and make it closed, and I say this, we say all the numbers greater than, x is all the numbers greater than 3 and less than or equal to 5. And that's how we will read that. It's just a group of numbers. Now for the or situation. So let's say -2 and then +2. I'll keep one open and I'll close the other one. So how will we write this? This will be the numbers. X is less than or equal to 2, or x is greater than 2. Now, could we write that as a double inequality, as a single inequality? So we do x is less than or equal to -2. I forgot to write -2 down here. That's a typo. Let's write -2, or x is greater than 2. So what you want to do with inequalities is solve them separately, write them separately, then join them in at the end. And now with inequalities, you can write 3 is greater than x, or you can write x is less than 3. You can flip the number and the letter as long as you flip the inequality. You can do that. But I would always tell you to keep the variable on the left, and then if you need to write a compound inequality, then flip it. That'll be much safer for solving problems. So let's talk about interval notation. This may be new to you, but we're going to need to talk about interval notation when we do domain and range. So what is interval notation? Interval notation takes our number line and writes it in a different way. So we go from 1 to 5. This almost looks like a point in a Cartesian plane, but we haven't gotten there yet. So let's talk about what symbols we have. We have a parenthesis, which means it includes that number. Infinity, negative infinity, and positive infinity, and we need to make a differentiation between the two, will always be in parentheses because you cannot include infinity. You cannot contain infinity. So parentheses get open circles because the endpoints are not included. So an interval puts the endpoints of a range of numbers at the end, and then all you have to do is determine whether you include it with a bracket, include it, so it gets a closed circle, and the parentheses excludes it. And as we can see on the final one, both endpoints of the set are included, and there's all the numbers in between. So this is special case. Interval notation will say interval notation, so you know it's not a point. Now, let's talk about set notation. What is set notation? Set notation lists elements of a set, objects. It can be numbers, it can be letters, colors, it can be anything. So let's look at what a set would do and what type of problems we get when we deal with sets. So we say, what are the list of months in a set? And we know the list of months. A set starts with braces, funny looking parentheses with a point. And we say Jan, Feb, March, and you know all the months, ... October, November, December. This is a set of the months, a set of colors, whatever you want to write in there, Roy G. Biv, as a set. Now, when we're talking about sets of numbers, we have to write this out in a funny way when we write sets of numbers. Sets of numbers, you're going to list your variable, the letter epsilon, Greek letter epsilon, such that, which means such that, it doesn't mean such that, it means containing. So here's your variable, x is your variable, the Greek letter epsilon is what number list are you choosing? What number set? Are we choosing natural numbers, counting numbers, whole numbers, integers, complex numbers? Usually you will see the real numbers will dominate most sets. You'll see that. Such that, and then you get some kind of comparative. X is greater than 2. And then you have to close your set with a brace. Now, we use this notation when a set contains an infinite amount of numbers. If we were containing a finite amount of numbers, like give me all the odd numbers between 1 and 9, 1 and 10. So you could just write 1, 3, 5, 7, 9, and you could just list that. Or you could do something like this, but instead of using real numbers, we would use natural numbers, and we would change that R to an N. So this is what was different about set notation. With a set, you have to list all the elements of that are possibilities in that set. And when dealing with numbers, your set can get very large. So you can write it this way, or believe it or not, this is a shorthand. Believe it or not, this is a shorthand, because on a number line, if I take 0 and I take 1, there is an infinite amount of numbers of points between 0 and 1, because I could go 0.1, 0.11, 0.111, and I could keep doing that infinite amount of times and mark off my points. And it would take me forever to get from 0 to 1. And that could be, 2,000 points right there that I showed you on that thing, on that number line. So remember, this set notation is believe it or not, is actually a shortcut to list numbers in a set. Okay, here it is written out, just to give you an example. The number set that are in the set, this is the variable. You have the variable in some kind of statement and some other statement, but you don't always need that other statement. And now these are set theory systems. We will often use the union because the union represents compound inequalities. So when you have a compound inequality, you're going to union two sets. You're going to join two sets together.